So this is a question from limits, and so apart from a trick which you can use, this question after the trick is straightforward and should definitely do this in exam in the first go. So the trick simply is limit t goes to x e to the power of t is equals to e to the power of limit t goes to x ft. When this limit exists, this is equals to this. This is what we are going to use. So we are given that this limit exists. So to make a given limit of this form, we'll simply write sine kx plus cos x plus x whole to the power 2 by x as e to the power of 2 ln sine kx plus cos x plus x upon x. So we are given that this limit exists and is equals to e to the power of 6. So the trick was that when this limit exists, it's equal to this. So applying it here, we get e to the power of limit x tends to 0 plus 2 ln sine kx plus cos x plus x upon x is equals to e to the power of 6, which gives us 2 limit x tends to 0 plus which gives us limit x upon x equals to 3. Now on this side we'll just apply L'Hopital's rule. Which states that this limit should be equals to the limit of the derivatives of the numerator and denominator. So differentiating the numerator, so d by dx of l in this whole thing will become 1 upon this whole thing kx plus cos x plus x into the derivative of this inner thing. So derivative of sine kx becomes cos sine kx into derivative of sine kx, which is k cos kx by chain rule, and by some rule we know that the remaining derivatives would be simply derivative of plus derivative of cos x, that becomes minus sin x, plus derivative of x, that becomes 1, and don't forget the whole would be below the denominator for this whole would be derivative of x, that is 1. So 3. So this becomes this. Now notice that this is no longer a 0 upon 0 thing, because the denominator goes to 1 as x tends to 0. So we can simply put x equals to 0 to evaluate this limit. This gives us cos sine 0 times k cos 0 minus sine 0 plus 1 upon this whole thing is 0. So sine 0 plus cos 0 plus 0 is equals to 3. This is cos sine 0 is cos 0, which is 1, into k into cos 0 is again 1. So k minus sine 0 is minus 0 plus 1 upon denominator is this thing 0. This is 1. This is 1 equals to 3, which gives us k is equals to